Looking at this offshore oil platform resting in the dark, an inactive rig appears calm to an outside observer. The heavy extraction machinery is quiet, and routine production has stopped. But to an operator, this state is deceptively volatile. Inside the structure of the BBLT platform in Angola's Block 14, the cellar deck sits at the very bottom. It is the platform's basement, a dense, labyrinthine level, packed tightly with intersecting pipes, valves, and critical infrastructure. When a planned maintenance shutdown begins, the normal rhythm of the rig stops. Almost immediately, the environment is flooded with external contractors and personnel who are unfamiliar with the platform's specific layout. Systems that are normally closed and highly pressurized are opened for inspection. Temporary equipment is hauled in, heavy machinery is dismantled, and dozens of new, unpredictable hazard points emerge across the decks. A maintenance shutdown transforms predictable, routine operational hazards into volatile logistical chaos. This top-down view illustrates SIMOPS, or simultaneous operations. During a shutdown, inherently dangerous tasks overlap in confined spaces, such as a welding crew working inches away from an open, unpurged pipeline. To prevent these tasks from triggering a disaster, platforms rely on permit-to-work systems. This administrative barrier ensures that overlapping jobs are scheduled safely and kept separated by time and space. The vulnerability lies in the sheer scale of the work. A major shutdown involves thousands of simultaneous tasks. When that volume overwhelms standard permit checking and isolation verification, procedures begin to drift. Workers are pushing through long shifts. Miscommunications occur between different contracting companies, and the mounting pressure to resume oil production degrades these administrative defenses. When permits and procedures are stressed to their limit, the physical safety of the entire platform relies on human discipline. By the deep night shift of May 20, 2025, that discipline faced a severe test. Darkness and natural circadian fatigue naturally degrade human performance and vigilance. In the dense environment of the cellar deck, verifying equipment isolation is difficult enough in daylight. With limited visibility, identifying a misplaced valve or an open line becomes a massive challenge. At 03:10 a.m., these overlapping risks culminated. A catastrophic fire broke out on the cellar deck, moving rapidly through the industrial corridors. The cellar deck's basement location acted as a trap. Thick smoke funneled through tight spaces, restricting visibility and cutting off access for immediate firefighting efforts. Platform-wide emergency muster protocols activated instantly. Amid the smoke and confusion, crews scrambled to coordinate a headcount and account for missing contractors. Survival now depends entirely on the crew's immediate emergency response. The onboard response teams faced an immense physical and psychological challenge. They had to navigate a labyrinthine, smoke-filled space, carrying heavy gear to control a fire they could barely see. Simultaneously, they had to coordinate medical evacuations in pitch blackness, packaging severely injured personnel for helicopter transport while stationed miles away from shore. 17 workers sustained serious injuries during the incident and the subsequent evacuation. 3 lives were lost. In the wake of such a failure, the quiet nature of a maintenance shutdown is revealed as a dangerous operational illusion. In the aftermath, the focus shifts to systemic vulnerabilities and the creeping procedural drift that led to the ignition. Investigations consistently show that when engineering controls and administrative permits fail, the final safety barrier is the physical readiness of the personnel. This requires rigorous contractor familiarization. Temporary workers must instinctively understand platform-specific hazards and escape routes the moment they step off the helicopter. Look at how OPIDO-approved survival training tackles this. By repeating the use of emergency breathing systems, the action becomes pure muscle memory. Workers learn to survive disorientation and blinding smoke without freezing. Specialized offshore emergency response training provides the next layer. It equips the onboard crews with the specific techniques to actively fight fires and execute rescues under extreme physical stress. Ultimately, this advanced training is the critical physical mechanism that prevents a localized hazard from becoming a mass casualty event. The offshore environment is inherently unforgiving. Crews are isolated, operating miles away from any immediate municipal fire department or medical assistance. While operators strive for zero incidents, crews train with the specific expectation that primary safety barriers will eventually fail. Simulated stress training ensures that a worker's first experience with panic isn't during an actual fire. They experience the adrenaline, the confusion, and the physical demands in a controlled environment first. Today, as modern maintenance and energy projects become increasingly complex, the offshore industry must securely scale these training standards globally. You cannot wait for a crisis to learn how to survive it. True emergency readiness begins long before the alarm ever sounds.